Hello, my name is Ben. I'm the Operations Manager for Immaterial, and our aim is to make gas storage and separation cheaper, cleaner and safer. Now we work with a field of materials known as metal organic frameworks, or MOFs. Now, these are porous nanomaterials that absorb gas much like a sponge absorbs water. What this means is that we can store far more gas at the same pressure at the same volume. We can separate one gas from a mixture without the need for distillation. Now, these have existed for over 2 decades. A lot of money went into researching them, especially by BASF, back in the early 2000s. Most of these projects never actually reached commercialization though, because MOFs form as powders. Now imagine having a cylinder filled to the top with a powder and trying to fill it with gas from the top. All that's going to happen is as you pump gas in, that powder is going to compact, and you actually get very little gas reaching the powder at the bottom. So, for any sort of industrial application, whether in a pipe or in a cylinder, you need to have larger pellets to allow the air to flow around it. But MOFs have always been quite resistant to this. You do it in one of 2 ways. Either you compact it under a lot of pressure, in which case the pore structure you had, a lot of it collapses, and so you get a significant drop in performance from the loss of surface area. Or you can use a binder, but now half your product is glue, and so again, you get a drop in performance. So ultimately, the field stagnated around this pelletization problem. You have excellent performance in a lab on a gram scale, but very poor scalability to any sort of industrial setting. It was until around 3 years ago, when one of our founders, a Cambridge PhD student, stumbled across a way to synthesize MOFs as large crystals, which we call monoliths. We patented this back in 2014, and have just gone into national filing. We found that not only do monolithic MOFs avoid a drop in performance, they're actually much denser, meaning we see as much as a 400% increase. In 2016, we took the world's leading material for natural gas storage and produced our own monolithic version. In doing so, we smashed the existing record and now hold the only material in the world to reach the target set by the US Department of Energy. The process is generic and can be applied to any of the tens of thousands of MOFs that are already known, dozens of which are already extensively researched and well understood. So, in a stroke, Immaterial's platform technology has made it possible to commercialize any of them, with applications ranging from natural gas transportation to carbon capture, hydrogen storage, and cheap, reusable catalysts. We therefore stand to offer substantial energy savings across a very wide range of industries, and we're entering the Imagine If competition to help fund the R&D we need to fine-tune our process, and for the ongoing mentorship to help us deal with much larger players in the chemical industry. Thank you.